Okay, so in this video we are going to look at getting the ball to move. Hopefully you were able to do the last section where you were getting the paddle R. So you had paddle left and you had paddle R. Hopefully you were able to get the key um, the key bindings done for that. So what I did in my one is that I changed it by 40 here. You might want to do it by 20, 40, 60, depending on how fast you want your paddle to move up and down. And as you can see, the up and down keys are actually written like this. So this you wouldn't have known. So maybe if you want to use up and down, this is how you would use up and down, but you may have used some other keys on the keyboard, but that's fine. You can just change them to those if you want to use up and down now. The next thing we want to do is look at the ball. So the ball at the minute is just this little square that we created using the turtle, and it is white and it is in the center. So what we want to do is start to get movement for it. So for the movement of the ball, what we need to do is basically set the ball direction on the X and Y axes. So I'm going to give this a go, and what we will do, we will set it to maybe 2 and change it if it needs to be changed to make it a bit faster possibly. So I'm going to do ball.dx. I'm going to say dx will be the direction of X, and that'll be 2. And then we will do ball.dy, and that's going to be 2 as well. So I've just done that in the section here where I've got the ball that I'm adding to it. Now the next bit to actually get it to move, because it's not going to move as such, if you run that, you can see that the ball just stays there. It hasn't moved or anything. So we've just set like a variable here saying that this is the kind of speed essentially that it's going to move. But what we need to do is we need to go down to the bottom, and we've got this loop that we're doing. So what happens in this loop is that it updates the screen. So anything within this loop we can change. So if we add extra code into this while loop, because while true, it's always going to be true. It's never not going to be true. Okay, so while true, keep on updating and then changing other things after this. So the thing what we can start to do is move the ball. So we'll put a comment and say move ball. Okay, so to move the ball, what we need to do is set the X and Y coordinates. Now the way to do that, if you can see up here for the ball, we've got this bit where we're just saying go to, but we can use set X and set Y just the same as we did here for our paddle. It's exactly the same thing. So here we're setting the Y, but we want to set the X and the Y. Now, what we want to do is set the X coordinates to be the same as the Y coordinate plus the direction, which would be this here. Sounds a little bit confusing, but as I'm saying it, but you'll probably get it whenever we write it. So what we'll do is we'll write ball and we'll do set X. Okay, so that is a method called set X, which we can set the ball to whatever place we want. So as you can imagine, I could just do 200 or something like that, and if I run this, the ball just shifted. See, it's just shifted one bit over, so that's gone over 200 on the x-axis, right? So it's done that, it's moved. So instead of the 200, as I said, what we will do is we will get this to update all the time. So what we want to have is to add whatever coordinate it is at the moment, because if we just do set x, as you could see what happened, it just moved once to 200, but then it just stays there, right? So here it'll always just go to 200, but we want it to be incrementing as such. So what we will do is we will say ball ball.xcore, as in x coordinate. So what we want to do is get the current coordinate. So the current coordinate when you start the game is going to be 0, right? Because we've said for our ball to go to 0, 0. So it starts off at being 0. And we will say set x to 0 plus, so I'm doing a plus in here. So this gets our position, our current x coordinate position, and then I will add that to the direction x, which we added up here, ball.dx, and I've set it to 2 at the minute, but maybe I'll change it later. Okay, so we'll say ball.dx. Okay, so we can run this now. Before we finish, just make sure you can see that these are methods, right? So this is a method that's been applied to our ball, which is a variable, and this method is the set x, but we've also got xcore method in here, and this is just, you know, an ability, something we can do, get the x coordinates, right? So if I run this, have a look, there you go, we've got the ball moving. And of course, because it's in this while loop, it updates. Now, of course, it just goes off the screen because it doesn't know that there is a border. So we have to actually, of course, program that in. Now, apart from the x coordinates, we don't necessarily want it to go straight. We might want it to go in some sort of direction, right? So we'll do the same for the y coordinate. So set y, open and close brackets, and then we'll say ball.ycore, which is going to get us the current coordinates for on the y-axis, which will be 0, and then we'll do ball.dy. Okay, so now we'll see what direction it goes. Okay, so it's now, by default, I suppose at the start of the game, it'll always probably float up to the top right. Okay, now I can see it goes quite slowly. If I want to speed it up a little bit, maybe I just put here 4 just to get it going. Right, okay, so there it is. It starts getting, it's a little bit faster, right? So it depends on your computer. Depends if you're on a MacBook or Windows machine, or you're on a Raspberry Pi, or you're on some other sort of Linux operating system. These things can be a little bit faster or a little bit slower. So I've just set mine to the direction of the x and y to 4, and that's a reasonable speed, I think, for it to start off. Now, the next thing what we want to do is actually check the borders. So kind of the top and the bottom border, right? Now, what we will do then for that is we're going to flip the direction. So if you imagine that the direction is going, so here we've got 4 and 4, right? So that means that it's always going to the top right. So every time I start the game, if you think about it, here in the center is 0. If I go to the right, that is on the plus. If I go to the left, that is on the minus on the x-axis, right? So if I do 4, it's doing 4 plus 4 plus 4 plus 4 plus 4 is going up that way, or it's going along this way. And on the y-axis, of course, this is in the plus and this is in the negative, right? So if you think of a line going across this for your coordinates, so it's going up that way, and it'll always go that way. But what happens when it hits this top border? So what we got to think about now is, where is this top border? So we have the size. We've got width of 800 and height of 600. So that means that roughly about, if we split that in half, that's 300. But you've got to then take into account the size of the ball. Now, what size is the ball? Well, this little square is, I think, about 20 pixels, right? So if it's about 20 pixels, then we want to kind of take that into account, at least half of it. So if it's about 20, then we're looking at about 290. that when it gets to sort of 290 here, that we want it to sort of bounce and go the opposite direction, right? So what we'll want to do is do some sort of increment on the negative. So let's do down here, this will all be from now on within the loop. So at this point what we do is we'll just say bounce off top and bottom. Okay, now you could do this, you have to do it this way of course, because if you imagine the game, your paddles cannot stop the ball here. It can only do it from past it. We can always only use this paddle to stop it from going off this side or this side. So it has to bounce off the top and the bottom essentially. Okay, just as if you were thinking something else about how that would work, right? So this is how I'm thinking it's going to work. So we just need to do a selection if statement. So we're going to say if the ball on the y coordinate is either greater than 300 or less, sorry, it's less than 300, like 290 I said, but it might be 280, we'll have a play around with it. Then we want to change it to go the opposite way, right? So we'll say if ball, and it's using the y core again, so if ball dot y core, so spell this correctly, y core is greater than, I'm going to put 280 at first and then try it out. So if this is true, okay, so if the y coordinates of the ball is greater than 280, and this is on the y, so this means it would be up here, right, somewhere up here. And remember where I got this 280 from, because we've got a screen size with a height of 600. If you change the screen size, then you're going to have to change some of these settings down here too, okay, because obviously it would be a smaller playing field. Now, what we will do is then set the y coordinate. So we will do ball dot set y to 280. Right, so we're going to set that to 280. So if the y coordinate is greater than 280, we want to just put it to 280. We don't want it to go past 280, essentially. So what happens is when it gets, well, when it gets to the coordinate 281, the ball will go back to 280. So you won't really see that whenever you see the animation. It'll essentially just go, it'll just be like a little flicker almost. You won't even notice it, I don't think. So the next bit then, we want to invert the direction on the y-axis for this. So it was our dy, ball.dy. So what we'll do is we'll say ball.dy. Now, this is short form. I'm going to show you the long form first, right? So ball.dy is equal to ball.dy multiplied by -1. So what that's going to do is that would actually change it to a negative, right? And it'll then be going down the ways, essentially. But we can do this in short form. So instead of that, I'm just going to do multiply equals -1. Okay, so now what we want to do is test this, see if it bounces off the top. So I'm gonna do okay to run it, and boom, it did. Right, so that didn't look too bad actually. So if I just run it again, just to play it out and see, okay, it doesn't quite hit off the top. So I suppose you could change it maybe to 290. And here we'll do 290 again. Just see what happens if it looks right a bit better. Okay, so there it looks like it actually hits the edge as such, because as I said before, the square, the ball, is about 20 pixels in height. So when it reaches to 90, 10 pixels because it's like the center of the ball reaches that coordinate. So 10 pixels of the ball are already at the edge as such. So 290 looks like a better number to use. Okay, so we've done that one. Now, essentially what we want to do is just do exactly the same for the bottom end, but we just change the numbers to be minus 29, right? So that's easy enough. So we'll just do elif ball dot y core is less than minus 290, right? So this will be on the bottom of the screen. So if you think here, the y-axis is going up and down. So here would be minus, right about there where my pointer is, minus 290. So I'm saying if this is true, then do this. If this is not true, go on to ask this question. And I'm saying elif, so elif this is true. And if this is true, what I wanted to do. Now, notice the way after the two dots, it indents. That's important, right? Because everything that's indented, these two lines of code, only get executed, only happen if this is true, right? So the same applies here for the elif. So I'm doing ball dot, and it's the same thing. Set y to make sure it doesn't go too far off the screen. To 290 it was, minus 290 this time. And then do ball.dy, and this time we will invert it again. So you imagine if the ball is going down the ways, then that means it's already going into negative numbers. So you would see what happens. We can actually print ball.dy and just see what the numbers are every time it happens, okay? And we'll do that now, just so that you understand fully how this is working, right? So we'll do minus 1 again, right? So here we can do print. We'll have to do it just on this one because the ball is never hitting off the bottom end at the minute, but it will, but it won't at the minute because we haven't got the paddle and so on. Right, so I'm just going to do ball.dy just so we can see this on the shell. So if I close this and run it, so I'm doing this print in here, and you can see then it said minus 4 there, right? So it only came up once. So what you can imagine is that this ball.dy is 4, right? And then it becomes minus 4. So it's then going on the negative. And then when it's doing this every single time, whatever the y-coordinate is, if the y-coordinate is 290, then it would be plus minus 4. So 290, then take away, so take away 4, and then we go on the negative doing that. Okay, so we can take out that print statement so you can see that that worked. Now, the next thing you want to do is also then think about where we have it going from the left and the right. Because at the minute, of course, what's happening here is it goes off, right? Now, what happens when it goes off? Well, we want it to change the points, don't we? So if it goes off to the left and to the right, you would get a point, right? So left and right, you would get a point there, okay? And the other thing we want to do is, of course, work out what happens when the paddle hits it, because like at the minute, it's like the paddle's got a hole in it, right? And the reason for that is because, of course, we haven't programmed it to recognize a paddle. So what we could do, first of all, is actually sort out the paddle bit, right? Now, this bit's a little bit more complicated because we have to do quite a long sort of if statement here. So I've actually tested and done this before. So, I had to do this many times. So paddle, collision, right, with ball. Okay, so with the paddle collision with the ball, we're going to have this for both the left paddle and the right paddle. So we can start off with, we'll do the right paddle first, and then hopefully what you could do as an exercise is do it with the other one, right? So I'll show you how to do how did we do it? Like, I'm going to keep this in order. So if I have left paddle here and then right paddle, then I'm going to keep these kind of things in order the way I've done it. So I'm going to have here, I would do the left paddle first and then the right paddle. Okay, so I'm just going to put in here code for left paddle collision, and you've got to then do this one, right? So I'm going to show you how to do the one for the right paddle, because that's the one that we want to see, because the ball is actually going in that direction when this game starts. Okay, the other thing would be the interesting thing that we could do is randomize the this ball direction. If we did a random, we could get it to go on the negative as well. But we wouldn't want just to be random, completely random. We would actually just want to choose between 4 or -4, right? So to choose between two numbers. So there is a possibility that we could look into doing that in future, so that the ball doesn't always go to the right. So you imagine the player with the right paddle always hits first. So you don't necessarily want that in your game. Okay. So the first thing we will do is, well, for this bit, you would have to do an if statement. Okay. So I'm just going to put if true, if true like that. Then I'm going to do pass. Okay, so this is the bit that you would have to do, this bit here. So I'm just going to leave that, and then underneath I'm doing an elif. All right, so this will be the one for the left paddle. So you're not going to write if true, you're going to have to write something similar to what I'm writing down here. Okay, now in the elif, what we're going to do is look at the ball on the x coordinates and the ball on the y coordinates. We have dot x core and we got y core, which we can look at. So we've got x core and y core of the ball that we need to find out, and we need to check on where it is, essentially. So if it goes on to the right hand side, where is that? Well, our width is 800. Now, where are our paddles? Our paddles actually start in a bit, don't they? So they are like here. Here I've got paddle right. So I've got paddle left is -350, and this one's 350. So that means if I think 350, I want it to actually be a little bit further in than 350. I would want it to be 340. If it's 340 maybe, right? So if I'm just thinking about this. If you imagine when the ball, all right, I've got an invalid syntax because this hasn't been done yet. When the ball hits over to the right hand side, where the paddle is, I want it to, like, if it's touching the paddle as such, right? So I'm gonna give this a go. So ball dot x core. So I'm going to get the x coordinate, and if I want to say if it is greater than 3, what was it? It was 350 is where the paddle is. So from the center of the paddle, if I think about the center of the paddle, where it is, the center of the paddle is 350, and you've got some pixels on the left. There's about 10 pixels, and then you've got the ball, which is another. Is that the center of the ball to the right is another 10 pixels, so actually about 330 maybe. So about 330. Okay, so I'm leaving 20 pixels from the center of the paddle and the center of the ball whenever they touch, right? So elif ball x core is greater than 330. And then I'm going to use an AND operator. Now these AND operators are used all the time in programming. They're used in logic gates. You learn this in physics as well, and or and not. And the AND operators, this is used so that we can check this condition. Is this true? And is something else true? And we're asking if both of these are true at the same time. Okay, so what we need to also do is find out where the ball, what the y coordinate of it is. So what ball dot y core. So if that is less than, I would say less than the paddle, the y coordinate of the paddle. Okay, so we're looking at the right paddle in this case. So paddle, it was paddle R, right? So paddle R dot y core. And right, so the y coordinate, right, so we're checking that one as well. I think we might have something missing that we need to add, but we'll have a go at this. And we will also then do ball dot y core if it is greater than. So this is like the bottom. We're saying about it being like at the bottom or the top end of our paddles, right, of the paddle. So we're doing paddle r dot y core, open those brackets, and two dots. Now, the only problem I'm thinking about this is actually the paddle y core. This is the center, and this is the center of the paddle. So this may only work if the ball hits the center of the paddle at the minute. So we're going to need to work out something else about this y core and this y core of the paddle. So I think we need to do that, right? So here we're going to do then, we're just going to change the direction again. So ball dot, and it's the dx one that we want to do. Sorry, dx, not bx. And to change the direction, it was this, wasn't it? So we just did this kind of thing here, which would be inverting it from a plus minus. So we do that one minus one. Okay. So I think we can try it now. Right. Oh. Okay. So. Right. So it got to the point where it went off the screen, right? So we have to kind of constantly rerun this. But you could see actually it doesn't hit the paddle as such, right? So I don't know if it's because it's something to do with the y core of the paddle. This y core of the paddle. I don't think this is right. So why is it? Well, if you think about the paddle here, that its length it's been stretched out, right? So this is a longer paddle. Now, this stretch width, I believe that this accumulates to being like sort of 50 pixels. And then the stretch, so the stretch width, stretch width and then stretch length. This could be possibly up to 100. So what we're going to do is we're going to put 50 in there. So down here, we will do paddle R plus y core, paddle R dot y core plus 50. And then on this other end, we need to do minus 50. So a bit of a gamble, but I'm thinking this is right. If you think about the length of the paddle, that it's going to be about 100 pixels going across here. Let's have a look. Okay, so it still didn't quite do it there. Elif x core is greater than 330 and ball.y core is less than paddle r.y core plus 50 and ball.y core is greater than paddle r dot y core. This looks right. I think I've got these in the right way round. Still doesn't work. Let me have a look. Try one more, just test it again. It should have hopefully have changed the direction, but it's not doing it. It's not changing it. Hopefully I haven't got my paddles the wrong way around. So if I just change this to L, I have typed paddle and change that to paddle L. Just out of curiosity, if I've got the paddles in the wrong positions as such, because sometimes you can't tell. No, it's nothing to do with that. Okay, so it is still, should be paddle R and paddle R here, but it's not inverting. So on this elif, full dot dx. Okay, so maybe I have to think about basically doing the rest of it. So we'll try and do this bit as well. And what we're going to do is just essentially copy this. So we'll copy this, put it here, change that just to an F, of course. And for this bit, it'll be, we have to change this to less than, and it's going to be on the negative, minus 30. And the ball.y core paddle L up here again. And it's plus 50, and here, that's fine, I think. So let's have a go at it. If it doesn't work, it doesn't work. We'll have to go back to the drawing board and fix it all up. Ah, here we go. Ah, look at that. We've got a game working now. That is... Basically, it's because of the if statement. So the if statement didn't do anything. It was doing, if true. So if true, it would just pass and do nothing. So that's why I had to kind of do the other one. It was a bit silly of me trying to do one specifically. Okay, so we've got a game that works, but we've got another lesson. So in the last lesson, we will do a couple of things. One of the things would be what happens when the ball goes off the screen. We would want to change the score, and we want the ball maybe to reset here to the center point, right? And then the other thing that we might want to do is every time you hit the ball, it speeds up a little bit. Now, if it speeds up, there probably would be a point where it would speed up too much. So you can see at the minute that the game's actually a little bit slow, right? So it's fine when it starts. You start off the game and the ball is traveling at a reasonable speed, but it's too easy to play, isn't it? This is the problem. So what we will do, we'll think about doing that, where we'll get the ball to speed up to whatever point we can get it to speed up to. There might be a limit to that speed, and then change the points, and then think about some other things like if we get to 10 points, then it's a game over, or somebody's won maybe, I'm not sure. We'll think about those kind of things for the next lesson. Okay, so that's it for now. You can just leave that bit and make sure these are all indented as part of this while loop, because this needs to happen over and over again. So this is essentially, as you can see, this happens again and again and again and again, and is always changing. That's why we're having this the window.update, and this while loop happens consistently. So this is how we're ending up with this ball moving, and this is how we are constantly checking these y coordinates to see if it's on the top left of the screen or the bottom left of the screen, and also if we're hitting the paddle or not.